Hello, everybody, and welcome to the third episode of Grade 10 Mathematics done by Rotaract Vikramasuriya from Rotaract Club of NSBM. And you're joining with the Road to A Plus initiative done by the Rotaract Club of NSBM. So it's been a great week. So today's topic is your chapter 3. Basically chapter 3 is fractions. Basically it's a very simple topic, and I will be moving very fast with it because most of you know what is fractions, and I will be more focusing on the applications of fractions mostly. uh, so let's get on with it. Today there is no I didn't create a slideshow kind of thing because I believe that it's a very simple. Yeah, we did perimeter. Perimeter was a new one, and not new, but there were new stuff. Sector was there, and let's take square root. There was something in that too, but in fractions, honestly it's a very simple one. So I thought of why let's take just the textbook and let's go get move into it. And but still my models will be the same, my theory applications will be the same, my way of teaching will be the same, where I will divide the work, I will tell you how it's happening, how the exam papers are, and all that will be happening. So let's move on to the textbook, and let's get started with the fractions chapter. Let me share my screen first. Okay. Yes, you guys can see the screen. So fractions. What is a fraction? The example is very simple. The example given in the diagram in the textbook is very simple example. They have said, like we all know, in a chocolate, in a Sri Lankan chocolate, let's say not just Sri Lankan, any chocolate with a slab sort of a chocolate, there will be pieces you can share with each other. So those pieces are basically, they say the figure depicts a slab of a certain type of chocolate. It has been divided into 10 equal size pieces, such as that the pieces can easily be broken off and shared with your friends. One piece of chocolate that is broken off is considered as 1/10 of the slab. Two pieces can be called as 2/10 of a slab. Basically there are 10 pieces. The whole chocolate is divided into 10 pieces. So what happens is, when the whole chocolate is divided into 10 pieces, if you take just two pieces, that means you have 2 over 10. Okay, 2 out of 10, you have two pieces. So that's why 2/10 of the slab. Three pieces, 3/10 of the slab, and it goes on just like that. That depiction of the 2/10, 3/10 out of 10, two pieces, that part is called the fractions. When you divide it, that's what happens. So they have shown the figure depicts how pieces of cheese have been arranged in a container, and 8 equal pieces are there. Same thing, they have said it in different examples for you to understand. Simply fractions is how we mentioned about the chocolate. It's very simple. So let's move on to what they're saying here. The unit has been considered here is the total mass of cheese in the container. No, the next one, please. When talking about fractions, it is important to be aware of the unit from which the fractions are obtained. Okay, this is this is interesting. Let's talk on this. It is very important to be aware of the unit from which the fractions are obtained. For example, in the statement, 2/3 of all the students in the class are girls, and the fraction 2/3 is applied by taking the total number of students in the class as the unit. So what they're saying is, to take a fraction, there should be something you're comparing with. You're comparing the chocolate when it had fully 10 pieces. share කරනකොට දෙකක් කඩලා දෙනවා වගේ යාළුවට. When you're giving it to your friend, there will be you're giving two pieces away. But that means from the original 10 pieces, you give 2. So that original 10 pieces is your comparison. That comparison, main comparison figure. That you should be aware of that unit. What is that unit? So in the chocolate case, it can be considered as grams, let's say. But here they have said it more clearly. 1/5 of the atmosphere consists of oxygen. That means the total unit is the volume of the atmosphere. 1/5 of the atmosphere is considered oxygen, because nitrogen is there, oxygen, carbon dioxide, and many other stuff is there. If you want to learn more about those, you should tune into our PD director Henry's science class. Definitely, she will be teaching those. Anyways, 1/5 of the atmosphere consists of oxygen. The volume of the atmosphere is the total unit. Then the second example, 1/4 of the 50 liters of water has been used up. So 1/4 of 50 liters of water. So 50 liters is the main comparison you are taking from. That is the total unit. 1/4 of the harvest was kept for consumption, they say. The total harvest, again, mulu harvest again, 1/4 they have taken for consumption. Basically, that is how we are comparing a total unit to the situation given. Okay, now we'll move on. The circular shape, I will erase this a bit. Definitely, I will erase it. The circular shape illustrated in the following figure has been divided into 6 equal parts. We know that, like, a circle can be divided. I said this in perimeter lesson. If you haven't tuned into our perimeter lesson, please do tune into our perimeter lesson, it was our first lesson, grade 10 mathematics first lesson. Each and every Thursday, Janet, your wonderful teacher, is coming to teach you guys on mathematics on perimeter 2 weeks ago, actually. So today is about fractions, so let's focus on that. Anyways, what I was telling was that the circle can be divided into infinite parts, but here they have divided into 6 equal parts. We know that the fraction that has been shaded is 2/6 of the shape. Out of 6 parts, that means 2/6 is your fraction here. The denominator, they said the denominator of 2/6 is 6 and the numerator is 2. The total number of parts into which the unit has been divided is the denominator, and the number of parts being considered is the numerator. That's what I was saying. The total unit, the total comparison unit is your denominator. Where you're comparing to 10 slices, 10 pieces of your chocolate. You had 10 pieces of your chocolate and you gave 2 away. Those 2, ladies and gentlemen, those 2 comes as the numerator. Denominator is the total value and the numerator is your what? Denominator is your total value and numerator is your considered value. Such here, if the numerator is smaller than the denominator, such fractions are called proper fractions. It's not a must to remember these per se. I mean, for the first term examination, if they ask, yes, but I'm not sure whether they will ask, because of the fact that it's a mathematics paper. It's not it's not an English paper where they're going to say, where they're going to ask what is a proper fraction and a unit fraction. I'm not sure, but for all of us, you will never get that. I'm 100% sure about that, because there's so many questions they can ask around fractions, even because there's BODMAS to ask. There's so much. Let's move on. Fractions such as 1/3, 1/5, 1/7, which the numerator is equal to 1 are called unit fractions. This is very, you should listen to this. When the numerator is very small, when the numerator is smaller than the denominator, it's called a proper fraction. Proper fraction. When the numerator is 1, it is a unit fraction. When the numerator, the value on top is 1, it's a unit fraction. So in the following figures, quantity is equal to 1/2, 1/3, 1/4, they have only taken 1 unit of whatever they have considered. That's what happens. So it is clear. Yeah, this is very important. Sometimes you will get to match these. I think you have done this in even grade 5, uh, where half is greater than 1/3, because you can see, look at that, half, the size of half is greater than 1/3, 1/4 is smaller than 1/3. So this ratio can be seen, this relationship can be seen. If we move on, we can see more of that. They're explaining how it's happening. The following figure illustrates three fractions: half, 2/4, and 3/6. How they are happening and all. Yeah. So here they have simplified. If you simplify 2/4, simplify meaning this can be, you see, this can be cut off, like this can be divided by 2. Both these numbers can be divided by 2. That will become to half. So that's why both of these are the same. If you take 4 parts, if you take 2 out of 4 parts, that will be the same as taking 1 out of 2 parts. That's half equals 2/4. That's what they have shown. And even 3/6 equals that. Okay, so this is fractions basically. Fractions, meaning fractions in the most simplest manner. The definitions of fractions and all, those are very simple stuff. You should have learned this stuff in grade 5. I'm 100% sure. Let's move on. So both the numerator and the denominator are multiplied by the same number. For example, to make, yeah, this is like, if you want to observe the fraction which are equivalent to a given fraction. Yeah. So what did I say? The 2/4 was equal to half. How did that become? How did that become? Was by, I said it can be divided by 2. That means it can be multiplied by 2. Like it can be divided by 2. You can make a, they can divide karo, you will get half. So if you multiply half by 2, both the numerator and the denominator, you will get 2/4. That's what they're saying. Then equivalent fractions are also obtained when the numerator and the denominator of the given factors are divided by the same number. 5 divided by 5, 1. 10 divided by 5, 2. So half again. It's a very simple one. You don't need to even remember it like this. Just remember, you can cancel this. 5 times 1, 1. Like you can straight away. Yeah, it's the same thing they have done. Yeah. Anyways, let's move on. Now let us consider the two fractions 2/3 and 3/4 obtained from the same unit, which are unequal to each other. Yes. First, let us write down several fractions which are equivalent to each of the fractions 2/3 and 3/4. It can be observed that among the, so they have, what they have done is they have multiplied by 2 and they have got 4/6. They have multiplied by 3, they have got 6/9. If you can say, I'm 100% sure you guys can see the cursor. 2/3 multiplied by 2, that's 4/6. 2/3 multiplied by 2/3 multiplied by 3 will give you 6/9. Likewise it goes, and they have found a small, small relationship. What is that? 12 in the denominator, 24 in the denominator in both of these. It can be observed that among the fractions which are equivalent to 2/3 and 3/4, there are some which have the same denominator. Our two fractions are too much such fractions. For convenience, let us consider which are the smallest common denominator. Out of these two, which does have the common denominator, which has a common denominator, they are considering the smallest one. So we obtain that 9/12 is greater than 8/12. Why is that? If somebody asks why is that, you should be always ready to answer, because this is 3/4 while this is 2/3. So you might be a bit lost here. That is the reason was I explained it a bit in a hurry, but let me explain it again. So if a person want to know whether 2/3 of 3/4 is larger, like when they want to compare what is larger, if somebody asks what is larger, 2/3 or 3/4, so how to compare that? The most easiest and the most simplest way is to multiply it by different numbers by 2, let's say, then they will get 4, 6 by 2, 6 or 8, and find a common denominator. You will find 12 as the common denominator. The least common denominator එක ගන්න. Least common denominator එකත් එක්ක තියෙන මුළු fraction එක ගන්න. After you find in that fraction, take those two fractions. So 9 is always larger than 8, and as the common denominator, you don't need to this stays as constant. You don't need to check on it. Then you will have to check only on 9 and 8. That's how that works. Hence 9 is greater than 8 over 12. That means 3/4 is greater than 2/3. You can see even the graphical representation shows us that there is a small that it is much more a bit bigger than the normal one. You have learned in earlier grades to add fractions with equal denominators. They have said you have learned, okay? So I will go faster. No, don't worry. How to add those? When there is a common, you should first of all check whether you have a common denominator. Done. Similarly, you know that the fractions here with equal denominators can be subtracted. Always check your denominators, people. That is a must when it comes to fractions. Always check your denominators. Number one factor when come to always check your denominator. Always check it. Number one factor. So 6 minus 12 will give you 4 over 7. Done. Just the normal subtraction methods. When adding and subtracting fractions of unequal denominators, the relevant fractions can be first converted into equivalent fractions and of equal denominators. How are we going to do this? Sorry about that. I removed the denominator one. No? I should not remove that. The equal denominator එකක් තියෙන්න ඕනේ කියන එක මතක තියාගන්න හැමදෙස්සම. When adding and subtracting fractions, okay, with unequal denominators, 2/3 plus 1/4. How do we add this? What is our method? We should always cross multiply. That's the most simplest method a person can do. But if the number gets bigger, you can try different methods. I will be teaching those when we are doing more complicated sums. So here it's the simplest form, like 3 is the simplest, 4 is the simplest. So hence we cross multiply. 4 into 2, 8. 4 into 3. When I say cross multiply, take 4 and multiply the whole fraction. When multiply the whole fraction. So 1 into 3, 4 into 3, 11 over 12 is your answer. Same here. 5 3 different. So we cross multiply. 4 over 15 will be your answer. 3 into 3, 9. 5 into 3, 15. Same denominator now. That's what I said. First of all, make sure each and everything has the same denominator. That's number one. You have to always check whether you have the same denominator. Okay. Fractions can also be used to represent quantities which are greater than unit. For example, let us see what quantity 3 over 2 of a loaf of bread is. This is the amount that is obtained when a loaf of bread is divided into 2 equal parts and 3 such parts are considered. That is how. Okay. Short is. So what they're saying is actually a representation. So how does, if a person says, yo, I have this much of bread, what does this mean? This means actually he has 1 plus half a bread. Why? When there's only a single number, what should we do when you're adding a fraction? We should always put 1. That is number 1. Then multiplied by 2, because you don't have the same denominator. Always check whether you have the same denominator. Multiply it by 2 and add it. Then you will get 3 over 2. That's how you're getting that answer, and that is more of a representation. You can they are saying you can represent 3 over 2 as this. You can represent 3 over 2 as this. So with that, we'll move on to another part. Hope you guys are doing great during this corona period. Hope you guys staying safe and all. And then if you guys have anybody, please do tell them to share these videos with them. This is where this initiative is a very great initiative for each and everyone who wants to learn, who wants to, we are not professionals, but we are trying to add value to each and everyone. So please do take the most of us. We are here to help you. Use us as much as you want. So back again to the game. If these three figures are considered together as one unit instead of separately, then the shaded region represents 11 or 12 of the unit. However, if any of these circles is taken as the unit, then the shaded region represents 11 or 4 obtain these. Okay, sorry about that. Yeah, it's happening. Accordingly, it is clear that 2/3 equals 11 over 4 when the amount is denoted by it is called a mixed number. What are they saying? If you can read it, honestly, these are not coming for your exam. That's why I'm also bored to even explain these, because these are not coming for your exam. I'm 100% sure. I'm not 100% sure. I'm 90% sure. Because so here they're talking about mixed numbers and improper fractions. When the amount is denoted by 2, 3, 4, it is called a mixed number. When it is like that, which will equal to 11 over 4, it is called a mixed number. When it is written as 11 over 4, it is called improper fraction. That you should actually a bit remember, because if somebody asks, you can say, I know that. At least this, the way of representing the fractions actually. So when somebody says a mixed number, you should represent it by like this. When somebody says it's an improper fraction, you should represent it like this. That's basically it. So moving on to multiplication, I think. Yes, they have shown multiplication. This is a good one. Because multiplication is a bit different. Why is multiplication different? Because the reason is we are not considering the same denominator here. That factor, what I said, is only applicable for adding and subtracting. When you're adding and subtracting, the denominator should be the same to straight away get an answer. Should be the same to get an answer straight away. But when it comes to multiplication, half of 3/4, which is represented by like this, can be multiplied straight away. 1 into 3, 1 into 3 straight away. Multiply the numerators, you will get 3. Multiply the denominators, you get 8. It's very simple. Addition and subtraction, denominator should be the same. Here, multiplication and even division, you don't need it. So, yeah. they're telling examples. You can read those examples, because I believe no, the graphical representation, do check those, because they will give you a proper understanding kind of way. It will help you to, you know, remember stuff. So how to do this? 1/3 divided by 1/6. Okay, how to do this? They are saying, let us find how many 1/6 there are in 1/3. This is denominated by 1/3 divided by 1/6. It is clear from the figure as well. So how do we do this? Is we have to first convert this into a multiplication. To convert this into a multiplication, this should be this should be multiplied. This should be multiplied. Here the explanation is a bit different, that's why I was checking. This should be multiplied by 6. It should give you actually 2. Wait. I'm a bit worried here. Wait. However, since half of any quantity is the amount that is obtained when the quantity is divided by 2, 3/10. The answer of this has not, they haven't showed that. They are showing something else, no? Yeah, that's why I was a bit confused. What are they showing? They're showing something else. Ignore that. So moving on, let's take this example. 3/5 divided by 2. When 3/5 divided by 2, we always know there is always a denominator 1 under it. Under normally divide, the answer will be the same. So to make it a fraction, for us to help in division, subtraction, addition, and multiplication, we always put that 1 and do our stuff. So we put that 1 here, and then to multiply it, we take the reciprocal. That's how this becomes half, and then it's 3/10. What do I mean by reciprocal? This is a good question, because I'm 100% sure. Like, if you know this is better. Like, if somebody say 3/5 reciprocal, 3/5 reciprocal is 5/3. What do I mean? 5/3 5/3. What does this mean? You are sending the numerator to the denominator and denominator to the numerator. That's how it becomes this creation. Yes. This reciprocal idea comes like that. This is the reciprocal idea, and that should be always used when it comes to division. Division method of fractions will always tell you to use the reciprocal when multiplying. That means what I'm saying is the method of division, divide by 2 over 1. So if multiply sign eකට හරවුවාම ඒක reciprocal වුණා. එතකොට අපිට answer එක ගන්න පුළුවන් very easily. Okay, moving on. Nice. I will do this bottomless one, and yeah, check what I have explained is here. Reciprocal part, what I have explained exactly is here. A over B is B over A. Simple as that. 3/5 is 5/3. So now let's take this. Sorry about that. Let's take this example, this big one. How to do this? First of all, you should know the BODMAS theory. The BODMAS theory, I don't know whether you guys have learned it, but I think if it's for the first time you guys are learning, let me teach you. No problem. BODMAS theory is a theory where we use when it comes to fractions. When it comes to simplifying and getting an answer of a fraction, we use the BODMAS theory. BODMAS theory says, it's a theory, okay. The theory says, first, number one, simplify the stuff inside the brackets. Whatever it is inside the bracket, simplify. Then simplify offs. Whatever says off, simplify. Then simplify divisions. That's number 3. Then simplify multiplications. That's number 4. Then simplify additions. That's number 5. Then simplify subtractions. That's number 6. So here you can see what have they done. Number 1, you should always make it a improper fraction, right? Yes, first of all, make it an improper fraction. 3 into 2, 6. So 3 into 2, how does you guys know how improper fractions work, right? Like I said, it's a representation, but I didn't explain it properly, I think. So how does 8, okay, this becomes 8 over 3, okay? 2, wait. 2 to this thing, how does it become 8 over 3? 3 multiplied by 2 will give you 6. 6 plus 2, here then it is addition. 6 plus 2 will give you 8 over 3. That's how you receive the answer as 8 over 3 here, which has converted it to an improper fraction. Now you're good to go. When you have your fractions very simplified, it's good to go. So what's the first thing we have to do? Brackets. There are 2 brackets now. So what should we select? The bracket which has the off, because second is off. You should always when it comes to a fraction simplification, go according to the BODMAS theory. So in here, off is in the second bracket. Hence we simplify that, and we we take on with that. So how are we going to do that? There's 5 over 3. There's 5 method 5 to 5 kapanawa. Hence it's 4 over 3. That's simplification has come down. So now after that we have to simplify this. How are we going to do that? They say addition, subtraction, so how are we going to do this? We have to, 3 and 2 has a common denominator, that is actually 6. If you multiply these two, cross multiply, you will get the same denominator. Always, I always said, make it the same denominator when it comes to subtraction and addition. Always make it in the same denominator. So moving on, here we will get 12 over 6 divided by 4 over 3. So how are we going to do it here? 6 to 12, it will straight away cancel off. Then you will get the answer 2. So 2 divided by 4 over 3. Then in the division, we always know number 1 in division is to find the reciprocal. Number 1 step in division method is to find the reciprocal. When we do the reciprocal, now it's 3 over 4. 3 is a numerator, 4 is a denominator. Then we are multiplying it straight away. This 2 get cancelled off, 4.5, 3 over 2. So they have represented it in mixed fraction, because it's much more better if you can always leave it like that. That is much more better. But it's okay actually, because I also have never done that. So it's okay, totally fine. Hope you guys got that sum. That is a very interesting sum to start off with the BODMAS theory. Always remember the BODMAS theory: brackets first, off second, divisions third, multiplication, addition, subtraction is then followed, and then Number one step, always change the mixed fractions to improper fractions. Then check for the common denominator. Do those stuff first when it comes to addition and subtraction basically. After that, check the Bottomless theory and do those stuff and simplify it at your will. So they have given questions for you to try. Unit fractions, select the unit fractions. You guys know what are the unit fractions? 1/7 වගේ තියෙනවා. ඒ කියන්නේ 1 උඩට තියෙනවා ඔක්කොම unit fractions. Proper fractions මොනවද කියලා ඔයගොල්ලෝ දන්නවා. Improper fractions මොනවද කියලා දන්නවා. You just have to put. Proper fractions are numerator is lower than the denominator. Improper are the other way around. Fill in the blanks is available. How they have obtained. Now they have shown you even. 4 into 3, 12 hour. I thought 3 into 4, 12 hour. And 2 into 4, no, that's 8. 8 over 12. It should be 8 over 12 here. That's a very simple ones. I'm not going to do those. I'm sorry, because honestly, these are very, very simple ones. I believe in, as I always say, you are a grade 10 student and you should be on your way to, you should be able to answer the exam paper stuff. So you guys can do this at home, but these are very simple. If there is any question you guys can ask, please do comment. I have not seen a comment, related to our related to the studies. I haven't seen a comment, but I see many comments saying the session was great and all, but no comments saying Nanitaya, what's this? Ask us questions. Share this with your friends. Share this with people who are in need. Share it with them because they really, really need it. Okay, I will do one sum from here, which is the fifth sum. Oh, that's a lot of sums there actually. I will do two then. Two sums. Let's check. Let's check the fifth sum because that's the first, theory based sum. There's a big question kind of way where you guys get scared. There's nothing to get scared. Whether the question is big or small, if you know your concepts, if you know your, what the question asks, if you know the concept, and if you know the information given in the question, the answer is there. That's what's that method. That's not my method. That's our concept of following answering any question in mathematics. If 3/4, so let's move on to the question. If 3/4 of a tank which was completely filled with water was used by a household for its needs on a certain day, what fraction of the tank still held water by the end of the day? If 3/4 of a tank which was completely filled that's not even a question. 1/4 is the answer. What are they saying? The household used 3/4 of the tank of the full unit. They have used 3/4. So how much is remaining? That means 1/4 is remaining. This is why I'm saying these questions are very easy. We'll move on to this one. This one seems better. If the two shaded regions of the circular lamina that has been divided into 8 equal parts as shown in the figure are cut out and discarded, what fraction of the total lamina is remaining? If these two parts are cut out and discarded, thrown away kind of way, how much parts are remaining? There are into 8 equal parts. That should be your denominator. So how many are remaining? If 2 parts are gone, 6. That is, you can simplify 3/4 divided by 2. I have divided by 2. Okay. What fraction of the total lamina is exactly half the remaining portion equal to? That is this actually 3/4 can right? Then they have asked what fraction of the total lamina is exactly half the remaining. Okay, that's not. Okay, that's a bit different. What they're saying is they're asking us what is half of the remaining. Now remaining is 3/4, half of 3/4. So half of 3/4. Half off කියලා දැම්මොත් off කියන්නේ multiplication එකනේ. එලිම off කියන්නේ multiplication. We learned it. Like BODMAS එකේ off කියන්නේ straight away multiplication. So half of 3/4 is something like that. Always check the denominator in addition and subtraction, not here. So straight away 3/8 is your answer. You know so that was a bit easier. We'll move on to the next one. Simplify. I will simplify this. This seems to be a good song. Let's do this. There's an improper fraction. What's the first step? First step, 5 into 1, 5. 5 plus 2, 7. 7/5 into 5/7 is this. I change the improper fraction. මෙතන reciprocal එක ගන්න, division method එක තියෙනවා, reciprocal ගන්න. අනේ ටික ලියා ගන්න පුළුවන්. It's okay, totally fine. After that, simplify. 5 to 5 cancel out, 7 to 7 cancel out. There will be a 1 plus here 2, 3/2. 1 plus 3/2 is equal to how much? This is 1/1. So multiply by 2. 5/2 is your answer. It was a bit fast, so let me go again. What we did was, first of all, change the mixed fraction into a improper fraction. How do we change that? Is 5 into 1 plus 2. Basically go through this method. Like go through that. 5 into 1, 5. 5 plus 2, 7. 7/5. So that cancels out. But always stick to the BODMAS method, which says brackets, off, and division. So division එක අපි ඊට පස්සේ multiply එකටම හරවගත්තා. ඒක මම මේ වෙලාවෙම ඒක කරේ cancel out කරන්න ඉස්සෙල්ලා. So when I turn into multiplication, both has the same priority. So I could cancel anything any way I want. That's what I did. So with that we got the answer 5/2, but never leave it like that. Always turn it into a mixed fraction again. Okay, so after that we had the tens sum. We'll do the tens sum too. Satish, who left home on a journey, traveled 1/4 of the journey by bicycle, 2/3 by bus, and the remaining portion by a 3-wheeler. What fraction of the total journey did he travel by both? Yeah. What fraction of the journey did he travel by both cycle and bus? By both cycle and bus. The fraction of the total journey did he travel by both bicycle and bus? Fraction of the total journey. So how are we going to find this? What fraction of the total journey did he travel by both bicycle and bus? 1/4 of the journey was traveled by the bicycle. Okay. And 2/3 by bus. Bicycling 1/4 ki. Busing 2/3 ki. What in 2/3 of what? The remaining. They can bicycling giyata passedi bus එක නේද තියෙන්නේ. එතකොට ඊළඟ ටික නේ. That means with the remaining තියෙනවා 3/4. So multiply by 3/4. Why? Because of 2/3 of 3/4 total එක. ඊට පස්සේ එයා කියන 3 wheel එකේ ගියාලු. Then they have gone in the 3 wheel. Remaining portion by 3 wheel. Remaining portion by 3 wheel. That means yeah, wait. I'm sorry about that. That means the 2/3 of by bus and the remaining portion by the 3-wheeler. You will get an answer here basically. Wait. 3 to 3 cancel. 2, that will be 2/4. and there will be another 1 over 4 because the total is 4. The total is 4, and we got 2/4 by bus. 2/4 is actually half. Bicycle by 1/4. So the other 1/4 is traveled by 3 wheel. Now we are moving on to the question. What fraction of the total? That's what. About the models balan. Video balan. Strategy balan. What did I do first? I check what the question has. The one of the question because what I always say is the concept. Check what the question has. There were some details the question had. I wrote them down. I wrote them down according to me, according to the concepts I know. I wrote them down and found some values. Now what are the questions they're asking? Now I move on to what are the questions they're asking. They're asking what fraction of the total journey did he travel by both bus and the bicycle. Bicycle like a bus. Bicycle 1/4, 2/4, that is 3/4. The answer is 3/4. The answer is 3/4. Okay. What fraction of the whole journey remained for him to travel by 3-wheeler? Because we found the remaining. Okay, let me go through this sum again, because it was a nice sum. I believe that is the level of your examination, first term examination. That can be closer to your that can be, yes, the level of your examination. Satish, who left home on a journey, travel 1/4 of the journey by bicycle. Mea bicycle in 1/4 key. That means remaining how much? Anitya hitaneba. 3/4 is remaining no. Now out of those 3/4, he travels the next 2/3 by bus. That means 2/3 of the 3/4. Remaining 3/4 he travels by bus. That's a value. Then the remaining portion of the whole journey is traveled by the 3-wheeler. So what we did was, we know the value of the bicycle. Now we know the value of the bus. We found the remaining value. Remaining value is 1/4. And then now we knew our concepts. We used our what is given in the questions. A circus dekama complete kara. And now we are moving on to what the question asked. The question asked, what fraction of the total journey did he travel by both bicycle and the bus? That means just an addition. Okay, for the addition, what are the two additions? Bicycle මේ value එකයි bus එකෙන් හොයාගත්ත මේ value එකතු කරාම වට එන උත්තරයක්. අන්න ඒක තමයි මේ. What fraction of the whole journey remained for him to travel by the 3-wheeler? We have already found that is this. So that's how this works. Hope you guys understood it. If there is any question, you can always ask from me. Do practice this type of sums. I mean, this types of, and also for BODMAS practices, do the 8th sum, and if there is any, I did this one, right? 6th one I did. So yeah, now we'll move on to the last part actually of this. No, there are further applications too. So there's 2 parts of this remaining. We'll move on to that. So there are 3 parts in this whole thing, where you are teaching about the fractions with BODMAS and all small ones, and then applications of fractions. Application of fraction actually we did now. So applications of fractions. Fractions are used in many calculations that come up in day-to-day life. These calculations can easily be carried out with a correct understanding of fractions. Given below are several examples of such situations. 2/5 of a mixture of flour prepared to make a certain type of food consists of Kurakan flour, while the remaining portion consists of wheat flour. A cook wishes to prepare 50 kilograms of this mixture to make the food item to cater to an order. Find the amount of Kurakan flour and wheat flour required for this mixture. Fraction of Kurakan flour 2/5. Quantity of Kurakan flour in the mixture 2/5 into 250 kilograms. that will give you the quantity of Kurakam flour in the mixture 20 kilograms. The quantity of wheat flour in the mixture 50 minus 20 kilograms 30 kilograms are the මොකක්ද ඒ උනේ තේරුණාද නැහැ අන්න ඒක නිසා තමයි I'm going to explain again. 2/5 of a mixture of flour prepared to make a certain type of food consists of Kurakam flour කියනවා. හරිද 2/5 of a mixture of flour. Kurakam මේවා දෙනවා 2/5. While the remaining portions of consist of wheat flour. Wheat flour ඉතුරු ටික. ඒ කියන්නේ 3/5 ලියාගන්න. 3/5 is wheat flour. A cook wishes to prepare 50 kilograms of this mixture to make the food item to cater to an order. Find the amount of Kurakam flour and wheat flour required for this mixture. 2/5. You find the amount of both. Question find the amount of Kurakam flour and wheat flour required for this mixture. So both of these 2/5 of 50 kilograms will give you 20. Yeah, what they have done is only they have checked one. They have found the Kurakam flour in the mixture. 2/5 of a mixture of flour prepared to make a certain type of food consists of Kurakam. So they have checked 2/5 of 50 kilograms because 50 kilograms are the mixture they are going to make for the catering part. So they have done that. So 2/5 into 50. 250 into 50. And they have done 50 into 2/5. 50 into 2/5, which have given them 20 kilograms, and they have subtracted and found the other remaining kilogram. It's basically you don't need to multiply it by the other amount. You can straight away get the answer because wheat and flour විතරයි තියෙන්නේ. Wheat and Kurakam විතරයි තියෙන්නේ. ඒක නිසා they have subtracted the other mixture. It's simple as that. Example 2, example 3, example 4. Please do check these examples. These are the models of how it can come to you. This example 4 is kind of good. I believe example 4 is kind of a good one. So we'll do that and move on to one of the questions given in the exercises. Example 4, a tank was filled with water up to 4/5 of its capacity. 4/5 of its capacity. After consuming 350 liters of this amount, the quantity of water remaining filled 1/3 of the tank. What fraction of the whole tank was used? Find the capacity of the tank. The quantity of water used as a fraction. 4/5 minus 1/3. So a tank was filled with water up to 4/5 of its capacity. After consuming 350 liters of this amount, the quantity of water remaining filled 1/3 of the tank. What are they saying? A tank was filled with water up to 4/5 of its capacity. After consuming 350 liters of this amount, the quantity of water remaining filled 1/3 of the tank. Okay, so find what the fraction of the whole tank was used. The quantity of the water used as a fraction of the whole tank is 4/5 minus 1/3. Quantity of water remaining filled 1/3 of the tank. So ඒක නිසා 4/5 minus 1/3, which will give you 7/15. And next part is then the next part they're asking is find the capacity of the tank, where 7/15 of the whole tank is we are taking as 350. Now we have found the quantity of the 350 liters is according to a fraction is this much. So 715 make a 1/15 key the capacity of the tank mulu capacity. This is simple scholarship exam wage question එකක්. pencil පාක ගාන මේක එක පැන්සලක ගාන කීයද pencil එසේන 20ක කීයද simple question so I don't need to explain it more uh, if you didn't understand this part let me give it a go again a tank let's say you didn't understand a tank was filled with water up to a 4/5 of its capacity okay tank purola 4/5 right on the 4/5 purewal on a mehema always if it's hard for you always draw the figure 4/5 of its capacity after consuming 350 liters of this amount the quantity of water remaining filled 1/3 of the tank. Again, the me 4/5 taking 350 liters. How they can be use it. Now remaining loop. This is remaining. 1/3 is remaining. So what is the fraction of the whole? What fraction of the whole tank was used? The quantity of water used. The quantity of water used then again me mulu ekama 4/5 nang we use this much nang and this is remaining this 1/3 is remaining hence 4/5 minus 1/3 then you get 7/15 and 7 no it pass find the capacity of the tank but capacity we always find capacity in liters we will talk about liters in volume this thing if 350 liters equals 7/15 1/15 equals 350 divided by 7 okay 7/15 equals 350 now 1/15 this is cross division cross multiplication kind of way we have taken the multiplication here 1/15 is this so then the whole tank this should be multiplied by 15 right because one is 1 unit whole tank this should be multiplied by 15 that will give you the answer with that I think we have talked about the applications in real life like me water make up that's a real life application then we took the Kurakan thing those are the real life applications of fractions and we'll move on to the we'll be moving on to the questions of this but actually I really need you all to do all the questions in this exercise 3.1 hence we'll be taking this fractions lesson to next week too because I believe fractions should be fractions is actually an easy one but it's a you see one of the most prominently used even in at O levels it will be used everywhere like whether it's volume whether it's area whether it's whatever the sum you need to simplify you will have to use it and most importantly I want you guys to try these out I want you guys to try these exercises out exercise 3.1 especially okay exercise 3.1 and we'll work on exercise 3.1 next week we'll start on with the answering of this and then we'll move on to the last part of it last part is our 3.2 further applications of fractions a bit harder ones where it gets a bit hard and we'll do that also so do 3.1 and keep it and we'll do 3.2 and also the past papers next week so with that I think for today we'll end the session so what did we do today we learned what is a fraction we went through how we add fractions how we subtract fractions how we multiply fractions how we divide fractions what is the most important fact when it comes to addition and subtraction the denominator should be the same when it comes to multiplication I mean any big hard fraction simplification, BODMAS should be measured. And then reciprocal should always be taken when it comes to the division method. So those are the most important takeaways from this chapter. And and then we we moved on to the applications of this chapter, and we did a lot of sums considering various parts like Kurakang, and that sum was really nice. And then we did the water sum. Well, those are sums which have a real applications in life, and I want you guys to do the exercise 3.1. It's not as a homework, just as a try it out. I am not giving homework. I'm not a person who can give homework to a person. Even I don't do my homework. But as an inspirational character, I should say I do my homework. So anyways, I want to take this chapter to the next week too, because I believe it will be better to do this chapter a bit slowly, because we touched many points here. Let me clear all my drawings and move on. We touched multiplication, subtraction, BODMAS, and all this, and we did Satish sum, the applications of fractions. Basically, that's the main fraction part, and after that we'll move on to harder sums where the applications get more complicated, and then we'll move on to the past paper examinations, the 2018-2019 Western Province past paper sums. There's only 2 to 3 questions in those. So fractions per se, like fractions, the raw fractions will be not a question that much, but fractions as a theory will be questioned everywhere, whether it's volume, whether it's addition, I mean whether it's area, it will be there. And most importantly, the fraction kind of this simplification and getting that point to this and that and all, this will be there in your, like, this will be carrying on forever. This theory is carrying on forever. That's why I want to push the BODMAS factor, the BODMAS theory into your heads. That's why I'm taking this slow. Let's see, it's okay, like we have time. We are not on a schedule like the normal lecturers, so I can take my time and do this. So now basically we know what is a fraction, we know how to add and subtract and divide and or multiply fractions, and we know the BODMAS method, and we know that the equal denominator should be there when it comes to addition and subtraction. And then we moved on to the applications of fractions, where we talked about different parts. We talked about volume based ones, and we talked about grams, I mean the food, the Kurakam thing one, mixture one. So we can see how fractions are used in real life. And then we'll move on next week to the hard sums with applications, and we'll do not all, but you guys have to try all of exercise 3.1. You guys have to try everything. I will be doing 8, 7, 6th and 5th, 3rd, yeah, 3rd to 8th. I will be doing all. And then we'll do this, and we'll move on to the past paper examinations, and with that we'll end the fractions whole lesson by next week. So let me stop sharing the screen. I think you guys, hope you guys learned a new thing. Hope you guys had a great day. I mean, the session was a bit good. I mean, better than last time, I think. Hope you guys know now what fractions is, what's happening inside fractions and all. And now you know whether when you're sharing a chocolate, whether how much of fractions are coming in and all. So with that, it's time to end. Thank you so much for watching. Thank you so much for listening to me. Thank you so much for commenting or sharing this video. Please, I again say, please do share this video with whoever this needs. I know there's so many people who I need to learn mathematics, who I need to learn science, who I need to learn English, whatever the subject. I'm not saying just my subject. when it comes to road to A plus, there's so many subjects, so many grades, 10 to 11, all 10 to 11, 9, every many subjects are there. So please do share with your friends and get this going, because we are trying to add value to you. We are not professionals, but we are trying to give you the best. Use us, ask us questions, and we are doing more past paper questions too. So basically we are covering a lot, 360 degrees of this. And so with that, it's time to end. But as the PR director, I should never forget to say this at the end of my sessions. Please if you are new, if you're a new viewer, if you're a new participant for Road to A plus or our NSB Rotaract page, please subscribe, please like this video, and then share it with whoever you think would get a good value from this. Please do. This is Jani Vikramasuriya, the Rotaractor Jani Vikramasuriya, signing off from Road to A plus, grade 10 mathematics. Thank you very much for listening. Next time, we'll do the other part of fraction. Till then, good night. Goodbye.